We've got a set of business partners working with each other. Kongsberg on the hardware side. Of course, they have Bathy processing software of their own. They're then working with Earth Analytic to take this in semi-real time into the cloud, into the ArcGIS platform, and creating data products basically as the ship is collecting data. It's really amazing. And so what Jacob has helped move along is to really scale that. So Jacob's going to set up the stage a little bit. I think Wetherbee Dorshow from Earth Analytic is listening in from Greece, where he happens to be competing on an X Prize team this week. And I'll let you take it away.
Thanks. All right. So we're going to go a little bit into the technical side of how we achieve this near real-time data ingestion from the ocean going vessels. Wetherbee, are you there?
I'm here. Can you guys hear me?
Yeah, loud and clear.
Excellent. So I can talk through the first couple of slides and then let you do the web demo. Does that sound good, Jacob?
Yeah, I think that's great. We'll dive into it.
Okay, so, a lot of words up here on the screen, but one of the things that I think might be clear to a lot of folks who have been familiar with ocean data is that while we have all these new amazing gadgets and technologies, AUVs that can go to 6,000 meters, there's been this lag between that technology and the ability to actually get this information into the hands of decision makers, And so one of the things we've been working on is how do we make it possible to get this rich, deep, complex ocean data into a web browser very quickly, and more importantly, how do we do it in a way where it can be almost in near real time and actually pushing data up into the cloud and leaving that data in the cloud, but then writing applications that consume that information. So go to the next slide, please. So essentially this is, a diagram that gives you an idea. You've seen these before, most likely. But basically, we want to allow all of these rich data sets to be centralized and accessible on the ship, on the shore. Basically, have eyes on shore, be able to access that information. Yeah. And that's what this product that we're calling SmartOcean is about. Next slide, please. So one of the core pieces of what we're calling SmartOcean is this product called SmartOcean Connect. And the idea here is that on the left side, one can see a variety of different data sets. Many of these are familiar to you. Bathymetry, backscatter, side scan, video, and even water column data, sub-bottom profiler. Typically, this is stuff that you don't get to really see unless you're looking at a desktop or until much later in the game. But what we've done is we've built out a solution on Azure that allows us to essentially feed this information to end users in near real time. Next slide, please. One of the concepts here is bathymetry and how do we update bathymetric surfaces in near real time. And so this is a conceptual diagram of what we've implemented in Azure. Could also be done in VMware. It could be done. We've been working on this with Kongsberg in particular with their new mapping cloud interface, which is built on Azure. And essentially, if you have ships like Okeanos that can have the budget of $1,500 a day to push data back to shore, which they're already doing, instead of just having that data go and fill up hard drives, essentially we can have it automatically be pushed into the cloud, and then using load balanced image servers, we can essentially be dynamically updating image services that then are served up leaving the pixels in the cloud. And this is really important. When you're talking about a lot of data, you pay every time you pull down that data and do something with it. We can also do the processing. So running QPS, running Chimera, for example, in that same cloud environment. We're already doing this now. We're working with JEBCO, Seba 2030 on some development tests of this platform, and with CCOM. And so, this is basically the way I think that, 5 years ago, I heard an example today that AUVs used to be kind of a scary thing for oil and gas companies in the ocean space. But now, you look at Ocean Infinity and they have 15 Huggins that cost, quite a bit of money. I think the same thing's happening with cloud-based data, and ocean data is really, in the end, something that we can treat like everything else that we're able to do now. So let's jump to the next slide. So with this, this is just a conceptual one to kick off. Essentially what we've done is we've built some scripts that allow us to dynamically update these image services, and all of these, the ArcGIS desktop is running in the cloud, and it's updating these services. So with that, I think you could bring up the web app and we can kick off a live demo here.
Yeah, here's hoping, right? So we're going to go ahead, and we have two Azure file shares that are set up, and one of them is the data coming in from the ship, and the other one is the data being ingested into the environment. So we're going to go ahead and start that process off of the ingestion. We're just doing it manually, so we can witness that. And there we go. We're already getting data. It's already ingesting data that quickly. It does this in batches.
Add to that, Jacob, is just that we have raster functions already applied. So in the table of contents, we could look at, and we only have a couple here, but we could look at the new Python's aspect and slope at one time, and run algorithms that can start hitting the pixels that are showing up on our screen without ever really pulling them down from the cloud. So we can be doing analysis, we can be generating charts. So I'm sure you guys have been hearing about all day some of the rich new tools with sort of the new hydrography. And this is a part of that. It's like, okay, we want decision makers to be able to use a web browser and instantly be able to leverage all that capability. So just to give you a couple more here, if you go to the next slide, SmartOcean Connect, here's an example where, and you can, we look at, this has a pop-up here, but you can see in the table of contents, we have many of the data types that we described. You can have, your SVP data in here, you can have other contextual data, but your side scan, the bathymetry, the sub-bottom, all of this stuff can show up in the web browser, and you can have these tools that we can then start kicking off these charting and other processes. And if you hit the next slide, you'll see we go, the best available data was said it was about 163 meters deep there. But then when we have the real data, we see that was about 30 meters off with, once we have the much better data. So obviously there's a lot of value to this. And so if we go to the next slide, and then here zooming in on some of the spot imagery that has been processed to 2 centimeters, we can look in great detail at shipwrecks and other features like this in the same environment. It's all georeferenced. And then, on the bottom left, there's this little inset of a giant sea sponge from the Nautilus. This type of data does not have to wait. It is essentially something that now we can push into a browser and allow folks to use it. Next slide. Magnetometer data, same thing. Obviously, simple tools for eyes on shore or even on the ship that aren't looking at desktop software can be annotating and assessing content that's coming in, and then making decisions about where to drill in and to do more processing of the high SAS data, for example, in areas where the magnetometer is suggesting there's a strong signal. Next, please. This is some screenshots from an extension that one of our partners and an Esri distributor, Geodata, has built for looking at seismics and sub-bottom data in a web browser. Really powerful tools. We've been working with these guys for a while. And here's another example, same web app, but now we can actually look at the subsurface. And on the right side, you see a German U-boat, and you can see how it's actually below it is a sub-bottom profile with that U-boat was, when it sank, went deep into the mud, and about 25 meters of it is embedded there. So once again, a web browser, and we're looking at this geophysics data that used to be really difficult to allow decision makers to look at. Next, please. So where do we go from here? It's not just about making these web apps that allow us to turn on and turn off lots of layers and do cool visualizations. That's sort of what SmartOcean Connect gets us started. But there's many applications like optimized routing of pipelines and using bathymetric data to solve business problems. So we like to think of this as like decision as a service. The first part is getting that data in the hands of people that are making decisions who don't have to be total techno geeks. And here are just a few examples of some of the applications that we're working on. For example, moving and decommissioning oil rigs, looking at dam siltation. It doesn't have to be in the ocean. There's some cases in BC where we're actually looking at tools for dynamically monitoring obstructions and providing that feedback through alerts to decision makers. Next, please. And then here's a screenshot from Smart Footprint. Is another product that we built over many years. And we actually got into the ocean space because of this. This is a corridor analysis that takes into account a whole bunch of data that was publicly available. But think about, essentially the value of being able to sequentially add in better bathymetric data, better understanding of the backscatter and habitat, and then rerunning these tools dynamically to make decisions. This is like $1 billion project, and 6 guys spent 4 days essentially doing early stage routing. But as we start to be able to leverage the power of the ArcGIS platform, we can be much more sophisticated in coming up with optimized routes that are going to save a lot of money. And maybe survey companies aren't going to be too happy because they're not going to make quite as much money. But in the end, I think it's one of these competition things. I mean, if the tools are out there, people need to start using them. Next, please. So just to wrap up, SmartOcean is really about these partnerships that Earth Analytic and Esri have been developing together. We have a very strong relationship with Kongsberg. Recently became an industrial partner with CCOM, working with Cardinal Point Captains on some interesting things. And then for several years, been working with GeoCap, which is owned by Geodata. Next slide, please. And we already touched on this one, so I'll just skip right through, but this, again, one of those examples. And then some of the apps and tools we're developing. I don't know how much folks have talked about Survey 123 and mobile in the ocean space, but tip logs, flow plans, scheduling, tracking, all of this stuff. This is what Cardinal Point Captains and Earth Analytic have been working on, leveraging the platform to be smarter about ways to record information and that sort of thing. So to wrap it up, I think we could go back to the web app if we have a minute here. And what I just wanted to show is that this near real-time Bathy is on here, but if here now you see, and it actually is showing this this sort of low quality QA data, and eyes on shore can basically be saying, hey, we got a problem with a sensor, let's look at that. And this is minutes after the data was pushed to the cloud. And then just to finish, we'll just show a few more examples so that you get the idea that high quality bathymetry is also something that then once it's all clean, we can go in and look at the side scan and zoom in on features of interest. Like there's that funny looking shape there, it looks kind of like a mouth. And if I come in a little bit further and turn on some of the process data, there's the U-boat, and you can even click on that ladder and see that here's a 2 centimeter model. I might not have the ladder in there. But those are rungs of the ladder that were going up the U-boat. And this is all in a web browser. So with that, I will turn it back over to Drew. Thanks so much.
Thank you, Wetherbee. And thanks for sponsoring from Greece. That's a pretty big move.
You bet.
Everybody loves the T-shirt, and we saved you one.
Well, and I appreciate Jacob standing in for us. He's been a big help. So thanks, everybody.
Yeah.
Happy to do it, Wetherbee.
So just to recap, everybody's used to getting some Bathy data and waiting a month or two to get your hands on it and do something with it. And here we are in semi-real time, scaling this up, right, Jacob? To what degree? I mean, whatever degree you have. Yeah. So fantastic, pushing the edge of what we kind of look at as a new flavor in hydrography, right? All right. Back to the best moderator on the planet. Caitlin Rains is going to backfill in some of the technologies and work that led up to these big implementations. So take it away, Caitlin.
We're going to spend the next couple of minutes answering some questions with bathymetry, and I think we should start with probably the most important one for this session, which is why and how do we map the ocean? Well, so we're really here this week to start answering that question for ourselves, for our community, and for the world. Everyone here is going to have a slightly different approach to this question. I've had the opportunity to work this past year, as in a couple of years, but this past year in specific, with a really new, exciting initiative from the GEBCO. They're trying to also answer this question. As to why they're mapping, well, I think I'll let them answer for themselves.
People say, well, what are you going to find there? Well, we don't know. And you don't know until you map it.
Mars is completely mapped. The moon is completely mapped. That's unacceptable. The public should not stand for that.
We'll use all of our collaborative efforts to reveal 100% of the ocean floor.
It's an investment in the future of not only the oceans, but of the world.
I believe we can help overcome poverty. I believe we can help combat climate change. I believe we can all make an incredible impact to the future of this planet.
A community, different disciplines, different understandings, different expertise, are all coming together to solve a global challenge.
You don't have to have much to start, but through creating partnerships, you can start contributing to ocean mapping.
Collaboration gives us more opportunity to complete the detailed and complete ocean map.
By joining forces, it's the best way for us to build the map and put all the pieces together.
More countries should get involved because the GEBCO grid benefits everybody.
We need to know more about our home. This is our world, this is Earth.
To be able to go to an area where nobody has surveyed before, saying, I filled that gap. That's a fantastic feeling.
We are talking about understanding the system that is vital to and without which life on Earth will not exist.
It is not an easy task, but if we can solicit your cooperation, we will be able to realize the goal.
In February of this year, Seba 2030 was officially launched in Tokyo. It's an undertaking by the General Bathymetric Chart of the Ocean, or GEPCO, to have 100% of the ocean floor mapped by 2030. And so this ambitious undertaking certainly raises several questions that we need to answer about bathymetry. First, why? Why does this matter? Well, the goal of Seba 2030 is to create the foundation needed to support the UN Sustainable Development Goal 14, to conserve and sustainably use the world's oceans, seas, and marine resources. This information is the foundation for all policy and research in the marine and maritime domain, and the goal is impossible to achieve without a comprehensive map of the seafloor. Well, that's great. Now we've answered the why. The next big questions are the what and the how. What exactly does it mean for the seafloor to be 100% mapped, and how do we make that happen? So we invited the Seba 2030 technical team here to the Esri campus in Redlands to start answering some of those questions. And we started with the what. What does it mean to have 100% of the ocean mapped? This is actually a surprisingly difficult question that involves several factors, from ships availability to instrumentation limitations. So for Seba 2030, 100% map means that in depths up to 1,500 meters, we have every feature greater than 100 meters mapped. From depths from 1,500 to 3,000, every feature greater than 200 meters is mapped. From 3,000 to 5,750 meters, that increases to 400. Anything deeper than that, Seabed 2030 wants to have every single feature larger than 800 meters mapped. So now that we know the what, we can start talking about the how. So Seabed 2030 is going to consist of 4 regional data assembly and coordination centers that feed data into a global assembly and coordination center, as shown here with the different colors of the regions. Those regional products that fed into that global product are now going to feed that GEPCO grid that this community has been working with for years. And in fact, you are going to see the impact of this initiative this year when the GEPCO releases the first 15 arc-second grid produced using Seabed 2030. You're going to start seeing 400-meter resolution data in your GEPCO grid. So now that we've asked a who, a why, a what, and a how, the next question is probably one of my favorites. It's where. Where does this lead us? Where does it show us where our gaps are? Where can we find opportunities to make this process easier? Where does this lead us as a community? Well, as it might be obvious, Esri's business is the business of where. So let me show you a couple of examples on how to answer some of these questions and some of the things that we're getting particularly excited about here. So first is this idea of where are our gaps? We can use dashboards, inherent technology in our Esri software package, to really understand where you might have gaps or where you might have data. Another really interesting piece of this dashboard is that you can use this to explain to yourselves internally, but also report out. So if you are working with an organization with disparate offices, each of those offices could have a dashboard like this to facilitate data sharing and information between organizations. Really helps you understand the where. Now, one of the things that we're realizing or talking about in the GEPCO community is that with the increase of the resolution of the grid, we're going to increase the size of the grid. And that means that people are going to have to manage it. Bathymetry is foundational data. Everybody in this room at some point has used bathymetry data. But you also probably know that it's a large data set that requires some knowledge on how to use it. So how do we facilitate getting people access to it so that you can ask questions like, where can I find data? And the answer is putting it all on the web. Here's an example of us allowing you to explore a bathymetry data set served as an image service on the web with metadata attached to it. So not only can you use this data as an image service, but let's say you're interested in data that's at a certain IHO survey order. You're only interested in special order. And this can dynamically shift so that you can understand your data in a way that makes sense for the work you're doing without having to learn some of these specialized processes or store this data yourself. And so we've been mentioning now that we have people who use bathymetry data. It's that foundation of an MSDI. One of the ways that we use data is for navigation. And a lot of this bathymetry data feeds hydrographic data. So you might want to say, okay, so where can I find data that makes sense for me to use in a chart? Or where can I find a chart itself? Imagine being able to, on your phone, be able to see ENC or electronic navigation chart data. And just zoom in and have it dynamically update. This is an example of a web service created and served by NOAA in their ENC viewer that allows you to see this type of data and actually query it. So you can not only just see the data that you would see in a nautical chart, but you can actually use it in a way that makes sense for the work that you're doing. And so now you might also say, okay, well, now that I can see this, I still want to be able to print a chart. We now can use that foundational data on the web of serving out the bathymetry image services and these ENC type services to allow you to create paper charts on demand. You're no longer going to be tied to having to use a standard paper chart with the cartographic finishing. You now can do it on the fly and get just the areas that you're interested in, which should facilitate your work as well. And the next where question, to really kind of wrap this up, is where does this lead us? What can you do with this? Why does this matter? And so I think what I want to do is encourage everyone here to really focus on that where. Where do we go next? Using hydrographic and bathymetric data in the web allows you to do things and visualize things that you've never been able to do with any real sort of ease. I work a lot with ports here at Esri, and so imagine a case where you have a design surface for a port, and you really want to understand the volume of material that you might have to use for dredging. Being able to do this on the fly means that you can really do some interesting 3D displays of dredging and bathymetric data throughout your region that really support your work and can facilitate. And this is just one example of the way that you can move forward in our technology and in your work now that we can have bathymetry data on the web in a manner that's easy and simple for you to use. So I really encourage everyone to keep thinking about that question of where does this lead us and where do we go next, and what you can do with this concept moving forward. Thank you.